All right, we're back. This is page 34 of math analysis, and it's kind of an intimidating page. Intimidating looking, at least. I don't know if it's intimidating to do. We will find out as we do it. So what we want to do is fill in the table below as follows. Find the principal coterminal angle. This definitely, we're using a calculator for at least some parts of this. Find the principal coterminal angle, fill in the reference angle, find the quadrant in which the angle falls, put a plus or minus in the box if the trig function of the original angle is positive. So it never makes sense to try to figure out if the trig functions of a reference angle are positive or negative. They're always positive. All reference angles come from quadrant 1. Everything is positive in quadrant 1. So like there'd be no point. So what I'm going to do, I'm going to use a calculator to find all of the coterminals to go through that process. I'll write them down as I go so that we don't have to switch back and forth. But let's switch over to the calculator. And I think what we should probably do is try to write a function to find the principal coterminal, which we've done before. So if you maybe saved that, hopefully, and you could just use it now. But if you didn't save it, let's see if we can do it. So think about it. So I'm going to call it P coterm. Maybe I'll just call it P because that's shorter of X. And then let's call it PC, principal coterm. Okay, so I need to take X. I need to figure out N, like the number of rotations. So it's going to be minus, we said we would use floor of X over 360. So that's the number of rotations, and then times 360. And I think that's it. Let me see. PC of 370, I know should be 10. Okay. And then 7, let's say PC of negative 10 should be 350. And it is. Okay. So this will work. So now I can just use this. What should I do? So I'm going to do such that X. So for the first one, I'll do just negative 4,665. And I get 15. So I'm going to write that down. All right. So now I'm going to try to do a couple at a time. So here, I'm going to say equals and then control and close parentheses. This is a list. So these are braces. Right, you got parentheses, brackets, braces. These are braces because they look. When you do a piecewise function, you have to do them. When you do a system of equations, you do them. This gives you a list. So I'm going to do negative 7,542, comma negative 3,110, comma 3,166, comma 2,056. So this is giving me. They go in order. So this will be 18 degrees. Is the first one, 130 is the next one, 286 is the next one, and then 256 is the next one. And then I'm going to do it again. So it's faster probably to delete that and then just kind of start a new one. So 207, comma, 2671, comma, negative 619, comma, 1933. I think that 4 is the most I can reason. Oh, 207. Yeah, why did I even bother? 207, 151, 101, 133. Okay, now let me do the last 4. So here, okay, so another of those, negative 780, negative 1623, 2578, and then negative 5021. So let's write these down. And then we'll go back to the notes. 300. Oh, that we actually know that one. That's a famous angle. 177, 58, and 19. Okay, let's go back to the notes and see what we can do from here. So share. Got to share the iPad again. Here we go. All right, so the quadrant, I'm going to base on where the coterminal angle is. So this is quadrant 1, 1, definitely 2. 286 is more than 270, so this is 4. 256 is less than 270, so 3. 3 because it's more than 180. 2 because it's less than 180. 2 because it's more than 90. 2 because it fits really well there. 4 because it's famous and also it's more than 270. This is just less than 180, so it's still in quadrant 2. This is quadrant 1 and quadrant 1. Okay, so without doing the reference angles, I could actually already fill in the pluses and minuses that I'm supposed to. So quadrant 1, everything's positive. So pluses across the board. You know what I'm going to do? I'm going to take advantage of the fact that I'm using technology and duplicate this. And this is also quadrant 1. Duplicate it again. This is quadrant 1. Duplicate it one more time. Quadrant 1. Okay. Quadrant 1 is done. Quadrant 2, sine is positive. Whoops. Sine is positive, which means cosecant is also positive and nothing else. And then I'm going to cheat again. So let's find all the quadrant 2's. Are there any others? Quadrant 2 is here. Quadrant 2 is here. And quadrant 2 is here. A lot of quadrant 2's. And quadrant 2 is here. Okay. And then quadrant 3, well, quadrant 4. All right, quadrant 4, only cosine positive, and therefore secant, it's reciprocal. Everything else is negative. Okay. And then let's cheat. So this is for quadrant 4. Are there any other, oh, were there any other quadrant 4's? This quadrant 4. And then all the others are 3. And in quadrant 3, tangent is positive. Okay, keep trying to write with the lasso tool. Positive, positive. Actually, it's probably just fastest to do this. Okay, tangent's positive, cotangent's positive. Everything else is negative. So I think we knocked that out. All right, let's do some reference angles. Quadrant 1, the reference angle is the angle. So let's go through and do those fast. 15, 18, 58, 19. Done. Quadrant 2, 180 minus the angle. So 180 minus 130 is 50. 180 minus 151 is 29. 180 minus 101 is 79. 180 minus 133 is 47. 180 minus 177 is 3. Quadrant 2, man, cleaning up here. Quadrant 3, I want to do the angle minus 180. So where are my quadrant 3's? So 256 minus 180 is 76. 207 minus 180 is 27. And then finally in quadrant 4, 360 minus the angle. 360 minus 286 is going to be 60 and 14, so 74. And then 360 minus 300 is 60, which is why that one's famous. We could have done the exact values if we had chosen to, which we did not. So I'd like to write a function that could give me the reference angles. And I think I'm going to try to do that right now. So if you want to stop, this is not essential. But what I'm going to do is I'm going to switch back to the calculator. And I'm going to try to write a function that gives me the reference angle. I want the reference angle. So how am I going to do that? All right, so I'm going to call it, rang of x. Now to do this, I need a built-in function that I don't know how you're supposed to, well, it's probably the if function, but I'm going to call it ifn. Ifn, I-F-F-N. So let me define a new little function here. F of x colon equals ifn, I-F-F-N, x less than 3. I want this thing to return 1. No, let's have it return, if x is less than 3, return 100. Otherwise, return 50. Okay, so if I do f of 1, 1 is less than 3, so it should return 100. And it does. If I do f of 3, 3 is not less than 3, so it should return 50. And it does. We're going to take advantage of this somehow. Let's see if we can. So we're going to do rang reference angle of x is going to be, all right, so ifn If in if in x is less than 90, I want this thing to return quadrant 1. So do I want to, I'm just going to say return Q1. I think this will work. Otherwise, return blah. Let's see. So let me try it. Of 10 returns Q1. If I do 100, it returns blah. Okay, so the key here is that the else thing, right? So it's if x is less than 90, return Q1. Otherwise, return something else, can be another if function. If in x is less than 180, return quadrant 2. Otherwise, what should it do? Otherwise, it should see if x is less than 270. If that is true, it should return Q3. Otherwise, so what am I going to do now? I'm going to say otherwise, if in the function, if in x is less than 360, I want it to return Q4. Otherwise, I think I want it to return quadrantal, because there is like, no, this, I think I just don't want to deal with that. Let's see. So rang of what? Wait, what am I doing here? Why am I returning quadrants? What am I doing? Reference angles. I got to go back and edit this whole thing. All of this is ridiculous. All I was doing here accidentally was returning the quadrant something was in. I don't want to return quadrant 1. I return the reference angle, which is x. I don't want to return quadrant 2. I want to return the reference angle, which is 180 minus x. Man, that was weird. Here, I don't want to return 3. I want to return x minus 180. And I don't want to return quadrant 4. I want to return 360 minus x. Okay, so I am aware this function will not work correctly, I think, for quadrantals. But I do think that it will work. So 10 gives me 10. 175 should give me 5. 191 should give me 11 because it's 11 past 180. And then, I don't know, 354 should give me 6. And it does. Okay, so now what I could have done is I could have done this function at x such that x equals, and I could just go through and do the same list thing, right? So this is set up to be successful, I think, for our, so we wanted to do this only on the principal coterminals, but 15, 18, 130, 286, I'll do a bunch, 256, 207, 151, that's like halfway, I think. So 15, 18, 50, 74, 76, 27, 29, those are the values we got. Go back, do it again, just finish checking, right? Like, why not? So here, what I go up to? 151, so 101, 133, 300, 177, 58, well, I already know these, 58 and 19. So 79, 47, 63, 58, 19, perfect. All right, so did you have to do this? Not really. Should you learn how to use your calculator in every possible way? Definitely. And this is a way you can use it, so I would definitely encourage you to try to play around with that. And like, think of other ways you could use it. There's like a ton of them. So what I'm gonna do is I'm gonna stop this here. I'm gonna come back in the next video and basically finish this up. It's kind of the same, except this time we're not gonna put pluses and minuses. We're gonna put the actual values. So it's more annoying, but like still not that bad. So anyway, see you in the next video when we will get that done. So I hope you find this helpful, and I will see you there.